Hello students, welcome to the next lecture on the numerical solutions of the ordinary differential equation. Today I will explain you the first method known as the Taylor's method. Myself Dr. Harish Garg, you can follow and subscribe my YouTube channel. Now whenever you have the initial value problem, dy over dx is f of xy, what is your target? Your target is to solve these differential equations and try to get the solution of the y in the function of the x. Once you are able to get the value of the y in terms of the x, then we called as the solution is closed form solution. We already discussed that you can utilize the homogeneous method, you can use as a variable separable method, you can use as a linear differential equations, or you can use as a Bernoulli equation, exact differential equations, and many more methods to find the implicit function y is equal to gx. For more detail about this, you can follow my playlist ordinary differential equation, and you can see the complete lecture series related to the variable separable, linear, homogeneous, Bernoulli, exact, second order differential equation, Wronskian, variation of parameters, operator, and many more lecture available in this playlist. Fine. But there are several examples where you are unable to find the exact solution of the differential equations. Once you are unable to find the exact equation of the differential equations, then our target is to find the approximate solution. For example, if I give you the one example, dy over dx is x square y minus 1. Fine. If you solve this example with the help of the linear differential equation, find the integrating factor, which is e raised to power p dx. Fine. And then finally find the solution. You are unable to get the integration exact form. So whenever you are unable to find the exact solution, we always look about the approximate solution. And how you can get the approximate solution? For that, we will utilize the numerical method. The objective of the numerical method is we can find the approximate or called as the iterative methods. What is the meaning of the iterative methods? We can find the sequence of the functions, the sequence of the approximation y1, y2, yn based on the values of the y naught, such that we can find the value of the y3 with the help of y2 or y1. We can find the value of the y4 from y3 or y2 or y1 and so on. That means we can find the nth approximations with the help of the previous approximation. There are the several methods existing. Few of them I have listed here. That is a Taylor method, Picard's method, Euler, modified Euler, and Runge-Kutta methods. In this lecture, I will start from the first method, Taylor series method. Make sure students, once we will start the Picard's method, we will discuss in deep about the Lipschitz conditions, existence and the uniqueness theorem, and many more lectures in this playlist. We will cover the 50 plus numerical examples so that you can crack any of the examination in a very simple manner. The first method we will discuss about the Taylor's method. The first method is a Taylor method, is a very simple method which are basically defined on the calculus. What is the meaning of the calculus is, once we talk about the calculus, that means we are interested to find the differentiation or we can find to integration. Fine. Once we are using as a differentiation, then the method is known as the Taylor's method. If we are using as the integrations, then we are called as the Picard's method. This is the first basic difference between the first two methods. For more details, you can follow this playlist and then learn about the difference between the each method. Now, in the Taylor series method, we are using as a successive derivative. But make sure, first question arises is, how do you know that the Taylor method is applicable or not? How do you know in the examinations whether the Taylor method is applicable or not? The simple answer is, whenever you will look about the function f, if the given function f is continuous and differentiation continuous and differentiable at the initial point x naught and y naught, then you can say the given function f is continuous and differentiable, then you can apply the Taylor series method. For example, if my differential equation is say x plus y and my point is y of 0 is my 1, then clearly say x plus y is continuous and differentiable at 0 comma 1. Yes, you can apply the Taylor series. Second example, I can choose an as say y over x. Again, we can choose as the same condition. Now, can you apply the Taylor series method? No. Why? Because y over x is not continuous at x is equal to 0. Fine. And initial condition is also 0. So that means the Taylor method is not applicable for the second example. However, if I change my initial condition, say function is my same, initial condition is say -1 is 4. Fine. Now clearly say y over x is my continuous at the point -1 and 4. Then yes, you can apply the Taylor series method at the function at the third example. So the basically when the Taylor's function or the Taylor method is applicable, you just look about that the function is continuous and differentiable. So the necessary condition is that function must be continuous and differentiable. Once you know the function is continuous and differentiable, then your target is to find the second derivative, third derivative, and so on. Can you find the second derivative? How you can find the second derivative? I can differentiate the equation number 1. You can differentiate equation number 1 with respect to x. Fine. The left hand side will be y double dash. How you can find the derivative? Because y is itself the function of the x. Fine. So that means you have to apply the chain rule. Fine. How you can find the chain rule? You start from the f, reach at the point of the x. F is dependent on the x, f is dependent on the y. You can see f is dependent on the x, f is dependent on the y. Then here, fine. How you can find the derivative of f with respect to x? How you can find? We can use the partial derivative. How you can find the f with respect to y? Find what is the derivative of x with respect to x1. Derivative of y with respect to x is dy over dx. Therefore, y double prime is कितने तरीके हैं आपके पास f से लेके x पे पहुंचने का. The one way is you can go in this direction. Fine. इस डायरेक्शन में आपके पास कितने तरीके आ रहे हैं? One is del f upon del x into 1. Fine. Second method क्या आपके पास? Second way you can go from f to y and then y to x. और उसमें आप उसके पास क्या क्या मिला आपको? Del f upon del y into dy over dx. That's the value of the y double dash. Fine. Once you know the y double dash, you can find the y triple dash, y fourth dash, and then so on. Therefore, by the Taylor series expansion, we can find the expansion of this case. If you simply take h is my difference between the points, find y prime at the point 0 is denoted by y prime at the point of the x naught. Y double prime at the point 0 is known as y second derivative of the y at the point x naught, and so on. If I substitute in the given Taylor series, we will get the required expression of the Taylor's method. Fine. Now based on this single way, I can solve the 10 plus numerical example in this lecture. And at the end, I will give you the 5 question as an exercise for you. Fine. You can solve it and let me know the answer in the comment box so that we can see how many of you can get the answers in a reasonable time. First of all, can you apply the Taylor method? Your function is x square y minus 1, which is continuous and differentiable at the point 0, 1. So yes, the Taylor method is applicable. What is given to you? X naught is my 0, y naught is my 1. Fine. Your function f is x square y minus 1, and you can find the value of the h is x minus x naught. What is the x? Your required target. Your target is to find the values at the 0.1. X naught is my 0. So h is my 0.1. Therefore, by the Taylor series method, we can find the y naught and then so on. So our target is to calculate the values of the y double prime, y triple prime, and so on, where y dash is already given to you. Now can you apply this? Can you find the derivative with respect to x? I can use the product rule. 2x into y plus x square into y prime. Now I can use as a product rule 1 into y plus x into y prime plus, again I can use as a product rule 2x into y prime plus x square into y double prime. Now you can see xy prime, xy prime. If you open this bracket, that expression becomes 2y 4xy prime. Again you can apply the product rule. Find 2y prime plus 4, 1 into y prime plus x into y double prime plus 2x into y double prime plus x square y triple prime. You can open this bracket. It's a 2 plus 4 is a 6y prime. Find 4xy double prime and 2x double y is a 6x double prime and so on. Fine. Now you can calculate, and if you want you can calculate the fifth derivative as well, but there is no need. Fine. Why there is no need, I will tell you. Now at the initial point x naught is 0, y naught is 1. Fine. You can calculate these derivative points. What is the value of the y prime? 0. Fine. Substitute करिए यहाँ पे value. X is my 0, so that is answer is minus 1. Can you calculate the second derivative at the point 0? X की value यहाँ पे 0 fill करिए, y की value 1 fill करिए. X will be 0, y prime is my minus 1. Because x is my 0, answer is 0. Can you calculate the third derivative? 2 into y. What is the value of the y is? Y is my 1. X is a 0, it's a 0 and 0. Can you calculate the fourth derivative? At the point 0, 6 into y prime. What is the y prime is? Minus 1. X is 0, y is x is 0. So your answers are here. Fine. Now you can see, क्या आपको स्टेटमेंट में कहा है कितने डेसिमल प्लेसेस तक करना है आपको? नो. फाइन. अगर कुछ भी नहीं कहा गया, then you have to calculate up to the 4 decimal places. Fine. You have to put your result in the 4 decimal places. और 4 decimal places के करने के लिए you have to do all the calculations up to the 6 decimal places. Fine. You have to do all your calculations up to the 6 decimal places. अगर आपके पास 3 decimal places में कहा है, then you can do all the calculation up to the 5 decimal places. Now substitute all these values in the given equations. Fine. Now rest you can do it by calculator. You can open these squares and then so on. Fine. अब मैंने यहाँ पे 2 fill करके 2 factorial से cancel हो गया. Y double prime is my 2. I can substitute 2 into 3 factorial is my 3 and so on. Fine. Now if you open this bracket और आप देख सकते हो up to the 4 decimal places is my 0. Fine. So there is no need of them. So the final answer is 0.9003 is the right answer. Look at the next one. Again, can you say the Taylor method is applicable? Yes, because the function is continuous and differentiable. Yes, the Taylor series is applicable. Firstly, I will find the values at the point 0.1. So your h will be 0.1 minus 0. Then based on the Taylor series, we can find its derivative. Can you find the second derivative? 1 plus y dash. Again find the derivative 0 plus y double dash. Next one is triple dash and so on. Fine. At the point x naught 0 and y naught 1. What is the value of the first derivative? X is 0, y is 1. That's a 1. Can you find the second derivative? 1 plus 1, 2. Can you find the third derivative? Third derivative is nothing but the second derivative, which is same as fourth derivative, which is same as fifth derivative, and so on. Fine. Substitute all the values in the given equation. You will get this expression. Now you can open that. It's a 1. Find 2 factorial and 2 will be cancelled. 0.01. 2 and 3 will be cancelled. It's a 001 divided by 3 and so on. The rest calculation you can do up to the 4 decimal places and your answer will be 1.1103 is the right answer. Now, how you can calculate the answers at the point 0.2? Fine. There are the two ways. Okay. Firstly, first method is I can replace the value of the y0 with the help of the y1. What is the y1 is? What is the y1? Y1 we have computed as 1.1103. Fine. And then we can find these values at the point of x1 is a 1 point. What is the x0? X0 plus h. Initial point is 0, then 0 plus 1 is 0.1 and the y1 is कितना से निकाला हमने 1.1103. Based on this value I can calculate y1 prime x plus y. So that will be 1.2103. Y double prime 1 plus y dash. Fine. And so on. Clear? Second method, this is the first way. Second method is you can take start from the x is by 0.2 minus initial value. But ये वाला method आप our target is to make h small as possible. h को हमेशा small लिखना है आपको भी. Fine. अगर तो इन्होंने स्टेटमेंट में ही लिख दिया कि h की वैल्यू 0.2 लीजिए. Fine. Then you can directly start from the h is 0.2 और इस previous method में h की वैल्यू 0.2 लेके यहाँ पे स्टार्ट कर दीजिए इसी इनिशियल पॉइंट के साथ. फाइन. आपको हमेशा h को जितना सबसे छोटे से छोटा ले सकते हो उतना लेना होगा. फाइन. लेकिन यहाँ पे ऐसा कुछ भी नहीं कहा. सो योर टारगेट इज फर्स्टली टू कैलकुलेट द वैल्यू ऑफ 0.1 and then use them to find the value of 0.2. Clear? Now you can substitute these values in the given equation. What is the value of the y1? y1 is 1.1103. What is the h? h is my 0.1. फाइन. इस केस में h कितना हो जाएगा? अब इसमें x0 की जगह पे x1 हो गया. फाइन. x1 will be my 0.1. So h is again 0.1. Substitute all these values in the given equations and after the calculation up to the 4 decimal places you will get the result is 1.2428. Fine. आप ये कैलकुलेशन कैलकुलेट से कर सकते हो. दैट इज अ वेरी सिंपल वे. Look at the third one. Can you say the Taylor method is applicable? Yes, because the given function is continuous as well as differentiable at the point 0,1 and your target is to express up to the only 4 terms. Fine. What is the meaning of the up to the 4 terms? Now here the term is up to the 4 term but up to the so far यहाँ पिछले में कभी भी 4 terms 3 terms तक नहीं लिखा. So firstly let me tell you the concept. Whenever you have the Taylor series, if you want to write the expression up to the first term, second term, third term, fourth term and so on, the meaning is first term is up to this expression. That means your Taylor expansion up to the first term is only y0. Up to the second term is your target is to write the first 2 terms. That means y of x is y0 plus h into y0 dash. Similarly up to the third term, up to the 4 terms and so on. Fine. So now in this example your target is to express up to the 4 terms. That means your target is to find the up to the third derivatives only. Fine. So let's start this again. x0 is my 0, y0 is my 1, h is my 0.1. So my target is to find up to the 3 derivatives only. Fine. So second derivative and third derivatives only. So can you find the derivative? It's a 2ex 2y into y prime. Can you find the next derivative? E raised to power x. So it will be y prime square plus y into y double prime. Fine. These are my derivatives. Now you can calculate these values at the initial point. x0 is 0, y0 is my 1. So what is the value of the y prime? 0. X is 0, e raised to power 0, 1. 1 minus 1, 0. Can you calculate the second derivative? E raised to power 0, 1 minus 2 into 1 and y prime is my 0. Answer is 1. If you calculate the y triple prime, e raised to power 0, 1, y prime is my 0, so that term is 0, minus 2, y is my 1, y double prime is again 1, that is a minus of 2. Answer is minus 1. Now substitute all these values in the given equations. Your answer is y at the point 0.1. Y naught is 0, h is 0.1. Sorry, y naught is my 1. Fine. Y naught is my 1. Y prime is 0 plus 0.1 square divided by 2 factorial of 1 plus 0.1 cube divided by 3 factorial of minus 1. Now rest you can do it by calculator, and then you will get the answer is 1.0052 up to the 4 decimal places. Look at the next one. Your target is to calculate the values at the point y is 1.1 and 1.2. Fine. अच्छा, अगर यहाँ पे ये चीज ना लिखी होती, फाइन, और कहा जाता y 1.2 पे निकालिए, देन यू कैन नेवर टेक, आपका x ये होता ना, तो आप x को 1.2 ले लेते और x नोट को 1 ले लेते, तो दैट इज 0.2 आंसर हो जाता है h. फाइन. तो यहां से आपका जो एरर आएगा वो काफी ज्यादा आएगा एज कंपेयर टू, सबसे पहले आप h को 0.1 लीजिए एंड देन कैलकुलेट द वैल्यू ऑफ द y इज 1.1, और फिर से दोबारा से h1 0.1 लीजिए एंड देन कैलकुलेट द वैल्यू ऑफ 1.2. बाय यूजिंग दीज टू स्टेप्स यू विल गेट द लेस एरर. ये वाला स्टेप आपको तब करना है वंस इट इज गिवन दैट यू हैव टू टेक h इज 0.2. लेकिन ऐसा तो कुछ नहीं ना कहा स्टेटमेंट में, देन यू हैव टू स्टार्ट विद द 1/1. फाइन. नाउ फर्स्ट ऑफ ऑल वी विल सी वेदर द फंक्शन इज कंटिन्यूअस एंड डिफरेंशिएबल. क्लियरली से द फंक्शन इज कंटिन्यूअस एट द पॉइंट 1, 1. Yes, the Taylor method is applicable. So we can start with this Taylor method. Our target is to find the value of the y dash. Y dash is given to you. Fine. You have to find the first 3 terms. Find the first 3 terms, that means up to the y double dash. So your target is to find only the second derivative. So that is a 1 into y of 1/3 plus 1/3 x y of minus 2/3 into y prime. That is my second derivative. Fine. Now you can calculate these derivatives at the point 1, and y naught is also 1. So what is the value of the y prime? At the 1, 1 is a 1. At the value of the y double prime, 1, 1/3, 1. Fine. 1 plus 1/3 is 4/3. Substitute all these values in the given equations. You will get the value of the y is 1 plus 1, y naught 1 plus h is my 0.1 plus h square divided by 2 factorial of 4/3. Now you can do the calculations and you will get the answer is 1.1067. Now for finding the value of the y of 1.2, we can calculate again these values instead of the 1. Now x will be your 1.1. Now basically your initial condition becomes, now your initial condition, instead of this initial condition, now your initial condition is y 1.1 is 1.06. I can substitute the values. It will be 1.1 into 1.1067 raised to power 1/3. You can use the calculator and get this value. Similarly, you can substitute the second equations. You will get the value of the y double. Fine. Substitute again in the given equations your y at the point 1.2. Remember, now it's a y1. Y1 will be your 1.1067 plus h is remain the same because h will be 1.2 minus 1.1, that is again 0.1. Now substitute the value. You can do the calculation up to the 6 decimal digits and then round off them to the 4 digits. You can see I do the calculation up to the 6 decimal digits and finally you can do round off them up to the 4 decimal places. Okay, can you apply the Taylor method again? Yes. because the function x square plus y square is a continuous and differentiable at the point 0, 1. You can see here is a 0.2. Fine. So if you start with directly with the 0.2, मैं इस एग्जांपल को डायरेक्टली सॉल्व कर रहा हूं आपके लिए. फाइन. बट यहाँ पे कहीं पे ये नहीं ना लिखा कि h आपको कितना लेना है, तो आपको पहले h को 0.1 लीजिए एंड देन यू कैन कैलकुलेट द वैल्यू एट द पॉइंट 0.1. फिर से लीजिए h एंड देन कैलकुलेट द 0.2. फाइन. मैं आपको इससे निकाल के दिखा रहा हूं एंड देन यू विल सी द एरर. What is the y dash is x square plus y square. Now calculate the second derivative. 2x plus 2y into y dash. Calculate the third derivative. 2 into 2 is a product rule. Y dash square plus y into y double prime and so on. Fine. You can calculate the third derivative and then fourth derivative. At the initial point 0, 1. Whenever x naught is 0, y naught is 1. What is your y dash? X is 0, y is 1. So answer is 1. Can you calculate the second derivative? X is my 0, y is equal to 1. Y prime is also 1. Answer is 2. Can you calculate the third derivative? Is a twice plus y prime is 1. So that is a 2. Y into y double dash is a 2 into 2. 4. Answer is 8. Similarly, you can calculate the value of 4. Substitute the values in the given equations. You will get the values at the point directly 0.2. Here h is my 0.2. Fine. Substitute the value and do the calculations. You will get as 1.272 is the right answer. But make sure, students, you can do it by own. Firstly, calculate h is 0.2, 0.1. And then again use h is 0.1 to calculate the values at the point 0.2. और आप देखोगे वहां पे आंसर इससे चेंज होगा. फाइन. So I assume I can say take h is 0.2, then only you can use this method. अगर स्टेटमेंट में लिखा हुआ है तो. फाइन. चलिए look at this one. Find apply the Taylor series up to the 3 significant digits. तो आपको कैलकुलेशन कहां तक करना है? You do all the calculations up to 5 decimal places. Fine. So पहले इसको थोड़ा सही फॉर्म में लिख लेते हैं. dy over dx it will be 2y plus 3 e raised to power x. So your f will be 2y plus, now clearly say this function is my continuous and differentiable at the point 0, 0. Yes, the Taylor method is applicable. Fine. So we can start with the x naught is 0, y naught is my 0, h is my 0.1. Then we can start with the y prime. Y prime is 2y plus 3 e raised to power x. What is the value of the second prime? 2y prime plus 3 e raised to power x. Find the third derivative. 2y double prime 3 e raised to power x and so on. Fine. You can calculate all these derivatives. At the given point, x naught is 0, y naught is 0. So can you calculate the y of prime? 0, 3, y naught double prime. 2 into y prime is a 6 plus 3, that is a 9. Can you calculate the third derivative? 2 into y double prime, that is a 18 plus 3. That is a 21 and so on. Substitute all these values in the given equations. You will get the calculated value here. You can do all the calculation up to the 5 decimal places and then you can do round of them to the 3 decimal places. At least 5 decimal places. Fine. So your answer is 0.349 is the right answer. Now these are the exercise for you. These are the 5 questions. You can do it by own. You can calculate all these values at the point 0.1. You can do yourself and let me know your answer in the comment box so that everyone can verify and itself me also verify whether you are able to understand this method or not. We will see the next lecture on the Picard's method very soon. Till then, you can share this video with your friends, like and comment on the video. Thanks for the watchings. Thanks for the spot. Good luck.